So we're going to start just with the office spaces here, which are found on the 3rd floor. This is a picture of what the inside of one of our offices looks like. There's usually 2 people per office. Nothing too crazy here. So from here we're going to head on over to 337, which is our main synthesis lab. Okay, so just to give you a feel of what the space looks like, we're going to do a really quick speed walk through the room. And then we'll take a more detailed look at important elements. As I mentioned, this lab is where the majority of our synthesis takes place, so the fume hood is particularly important for safely mixing chemicals, and so that's what this fume hood is used for. And the second fume hood in this lab is shown here, and this fume hood houses a homemade breakthrough system which can be used to produce breakthrough curves for a variety of gases. Shown here is a dry box, so some of the chemicals and materials that we work with are sensitive to water, including water that could be found in ambient air, so in that case the dry box would be utilized. We have several ovens that we use for synthesis, since most reaction conditions are at higher temperatures. So we have isothermal, programmable, and vacuum ovens, which are shown here. Here is the first adsorption instrument in this lab. It is a volumetric adsorption instrument called the Gemini, and it can take nitrogen isotherms for 1 sample at a time within a few hours. This instrument is a volumetric adsorption instrument as well, and it's called the Quantichrome, and it can take nitrogen isotherms for up to 4 samples at a time. So we use this instrument to get information about material characteristics like surface area and porosity.
This is another one of our labs on the 3rd floor in Bunger Henry. So just to start out, on the right we've got this CO2 breakthrough that one of our 2nd year students is using. She's basically inherited it from a postdoc who kind of built it. You can tell the whole thing is pretty homemade looking. So moving into the rest of the room, we've got another home-built instrument here on the right. So this is our multi-component volumetric adsorption system. We've got a water bath on the left, a GC on the right. So turn to the left here, we can see basically there's going to be an empty fume hood there in the back corner. And then in the foreground we've got some parts of a breakthrough system that one of our 2nd year students, 3rd year students has been working on. And then finally we've just got some synthesis ovens up under a fume hood. So just to talk a little bit more about some of the instruments that we saw in the video for the 334 lab. So this is the multi-component volumetric adsorption system. So basically with this, I built an instrument with the help of some of our postdocs and alumni who have since left the group, basically to measure adsorption of mixed gases. So with this on the left we can see a water bath. That's going to control our temperature. Then this big guy in the white with the safety label attached to it, that's a gas chromatograph. It's going to measure the composition of our gas as we adsorb it. So this again is the CO2 breakthrough instrument that some of our older postdocs built, and then our current 2nd year student Lape has been operating this. So here we've got basically this aluminum framework, and then you can see there's a lot of valves there basically controlling how all the gases are going to flow through it. And so rather than a gas chromatograph or a mass spec, this actually just uses a CO2 sensor, which is a much kind of easier plug-and-play option, much cheaper, but it does the job for the CO2 breakthrough. So here, basically this is kind of in the entryway of the room. I kind of skipped over this in the video, but here we basically can see a couple of racks of some hardware. This is all, tube fittings and so on. And then on the far right there, we've got our pelletizer that we can use to basically press powdered adsorbents into pellets, which are going to be much more usable for a lot of the measurements that we like to do. Today I'm going to show you around 269, which is one of our 4 labs in Bunger Henry. So we'll start out right here. We've got the sample prep station for some of the adsorption instruments in this room. Over here we have our TGA, where we can basically heat up a sample and measure how the mass changes as we're burning things off. Here we've got the Micromeridics 3-Flex, which is a volumetric adsorption instrument. We can run 3 samples at once on this. This thing is fantastic. So good actually that we have 2. So at the far right of this shot you can see that there's a 3-Flex with a cryo unit on there. so we can measure very low temperature adsorption. And then here we've got the first of two of our IGAs, which are gravimetric adsorption instruments, which are better for a little bit more high pressure adsorption measurement. So we've got two of these. This one that I'm showing now can run water vapor adsorption as well as gases. Here we've just got some more bench space for sample prep, sonication bath, got a fume hood. You can see it's kind of a mess right now, but not too bad, and that's pretty much everything for this lab. So this is the TGA, so what we can do with this is basically heat up a sample, and as it's going to heat up to hundreds of degrees C, different parts of it are going to decompose. So if we take a metal organic framework, for example, there's going to be an organic component which is going to burn off around 200 to 300 degrees C, and then a metal component which is going to basically oxidize at higher temperatures and form a metal oxide. With this, we can basically look at some of the components of what our adsorbents are. We can see, for example, maybe we want to put a sample on here that's had some adsorbate stuck to it, and we can basically figure out, what temperature we're going to need to activate it when we put it on some of the other instruments. So moving on from this, we've got some of these volumetric adsorption instruments. So these are the 3-flexes. You can see this picture is a little cluttered, but if we look at the table in the foreground, we can see there's a computer, and then to the left of the computer monitor, there's an instrument right now. It looks like the dewar is raised up, so someone is running a sample on it right now. Basically, that instrument and the one to the far right of the same table are basically capable of measuring low pressure adsorption of many different gases across a huge range of temperatures. So the instrument on the right, we've got the cryogenic unit, so we can measure down very low, below liquid nitrogen temperatures. So moving on from there, we've got the two gravimetric instruments. So like I said, the volumetric instruments are good for low pressure adsorption. The gravimetric instruments we're going to use for high pressure adsorption. These have fairly similar capabilities. The one on the right, we can do vapors, so we can measure adsorption of water vapor or any other liquid with an appreciable vapor pressure. And that pretty much wraps it up for these.
This is the Acid Gas Laboratory located on the 4th floor of Bunger Henry. The Acid Gas Lab is shared amongst the Walton, Lively, and Jones groups. This lab was specifically built to safely handle the acid gases hydrogen sulfide, sulfur dioxide, nitrogen dioxide, and nitrogen oxide. Acid gases are held in the gas cabinets on the left of the room here. The room is constantly monitored for accidental leakage of acid gases using sensors. This is the IR system co-managed by the Lively and Jones groups. IR is a spectroscopic technique used to identify unknown samples based on their chemical fingerprint. This is a home-built micro-breakthrough system capable of testing a variety of gases, including several acid gases. The system is automated and utilizes an infrared detector system to monitor the gas concentration. The system is capable of both high and sub-ambient temperatures. Next is the mass spec breakthrough system that we have here. What this automated and home-built setup can do is measure acid gas breakthroughs on powder samples. The gas compositions are tracked using the mass spectrometer on the left here. The system can also do humid acid gas exposures. This is the newest addition to the Acid Gas Lab. This is the pressure swing adsorption instrument managed by the Lively Lab. It's also equipped with a mass spectrometer, and it's housed in this enclosure to ensure any leakage of acid gases would go into the exhaust right above it. We will also have one more instrument in the near future. It will be a pressure decay instrument that does volumetric measurements. It will measure pressure changes under constant volume, constant temperature conditions to calculate adsorption uptake.